Hi guys, it's Simon C. Welcome to this new AI radar with my 3 favorite artificial intelligence news for today. Using AI to save bees. AI to decipher rat squeaking. AI recognizes giraffe torsos. Everybody loves bees. The École Polytechnique Fédérale de Lausanne published a video later last month explaining how a beekeeper teamed up with the Signal Processing Laboratory 5 and a group of EPFL students to develop an app that counts the number of varroa mites in beehives. This parasite is one of the 2 main threats, along with pesticides, to bees' long-term survival. Knowing the extent of the mites infestation will allow beekeepers to protect their bees more. That's what made Alain Bougnon, a local beekeeper, come up with the idea for the app that would provide this information, and teamed up with EPFL's Signal Processing Laboratory to create it, explained EPFL on fees.org. Then EPFL students built a system consisting of an app linked to a web platform that uses artificial intelligence to quickly and automatically count up the mites on the boards so that beekeepers can keep close tabs on infestations in order to target their treatments, which are in keeping with Swiss organic farming practices. The app can spot and count the dead parasites on the board in just seconds, thanks to machine learning algorithms trained upon a database of thousands of images of varroa mites, so that the app can recognize the mites on its own, and without making mistakes. Beekeepers jumped in to give the students feedback on their results in order to help them improve the algorithms. This app analyzes images taken by beekeepers to store varroa recognition results and create statistics, and to collect data. The collected data, could be also used to map out and track varroa infestations in Switzerland and potentially identify parasite-resistant strains of bees. Gizmodo's contributor Sarah Wells writes that a new project of researchers at the University of Washington aims to better decipher the squeaks and chips of mice and rats by using deep learning to more quickly and reliably analyze their chatter, helping them to understand what they're really saying. The work is called Deep Squeak, and it uses deep learning and machine vision approaches to categorize the enigmatic chips of mice and rats. In particular, explains Wells, Deep Squeak transforms audio recordings of rodent calls into sonogram images and then uses machine vision to analyze them. A paper describing the project was published in January in the journal Neuropsychopharmacology. Okay, we can train the software to analyze these calls in a way that is much more similar to how humans learn, said Kevin Coffey, a lead author of the report and co-creator of the software. Rather than mathematically describing what a vocalization is, we just show it pictures and examples. Rodents are naturally vocal animals, and previous researchers tried to associate certain vocalization with corresponding emotional states. The researchers behind Deep Squeak hope they too will contribute to a more nuanced understanding of these sounds. This is an inexact science, so researchers behind Deep Squeak hope they too will contribute to a more nuanced understanding. Okay. Coffey and his co-creator Russell Marks taught Deep Squeak to recognize different sound groups, such as distinct syllables or patterns of background noise, by first feeding it manually labeled calls. Then the software transforms a given audio trace to categorize the hills and valleys of the waveforms, recounts Wells. The ability to minutely detect and filter out background noises is particularly important when working with rodents, said Giraffe. Their software helps by not only reducing the number of misidentification in manual analysis, but also analyzing calls up to 40 times faster. Now you'll understand your pet rat better. Futurity.org contributor Gail McCormick reports that a new automated method makes it easier for wildlife researchers to use photos to identify the unique markings of individual animals. The problem in this case is, in the words of Derek Lee, Associate Research Professor of Biology at Penn State and Principal Scientist of the Wild Nature Institute, that many researchers need to identify and collect data on specific individuals in their work to estimate survival, reproduction, and movement. Lee uses photographs as a part of a large ongoing study to understand births, deaths, and the movement of more than 3,000 giraffes in East Africa. In particular, he and his team take digital photos to each animal's unique and unchanging spot patterns to identify them throughout their lives. But manually cropping each photo or drawing an area of interest to analyze it with pattern recognition software creates a serious bottleneck, writes McCormick. So Lee collaborated with scientists at Microsoft, who have provided a new image processing service to automate this essential and time-consuming process using machine learning technology deployed on the Microsoft Azure cloud. The system achieves near-perfect recognition of giraffe torsos without expensive hardware requirements like a dedicated high-powered graphics processing unit, says Lee. The new system will dramatically accelerate Lee's research on giraffe populations, which have rapidly declined across Africa due to habitat loss and illegal killing for meat, adds McCormick. Oh, okay, guy. It's all for today. See you next time with AI Radar. Bye.